the birth of Tesla's AC induction motor, and the race for power. In the winter of 1886, a tall, unassuming man, Nikola Tesla, arrived in New York City, carrying with him visions of electrical innovation. Having struggled to find investors for his ideas, Tesla's luck changed when he met a savvy businessman, Alfred S. Brown, a superintendent at Western Union, and Charles Peck, a New York attorney. Brown and Peck had experience launching inventions and negotiating patents for profit, and Tesla's bold ideas caught their attention. Among these was a revolutionary concept, a new kind of electric motor powered by alternating current AC. AC, a technology slowly taking hold in Europe and the US, promised to transmit electricity over long distances, something direct current DC struggled to do. Intrigued, Brown and Peck agreed to finance Tesla, organizing patents and securing a laboratory space at 89 Liberty Street in Manhattan, where Tesla began developing his AC technologies. In 1887, Tesla achieved a breakthrough that would reshape the world's electrical systems, an induction motor powered by AC, unlike DC motors, which required regular maintenance and produced dangerous sparks from mechanical brushes. Tesla's AC motor was simple, self-starting, and brushless. This was possible because Tesla's motor generated a rotating magnetic field using polyphase currents, a concept he claimed to have conceived in 1882. By 1888, Tesla was ready to present his invention to the world, hoping it would spark the interest of investors. Brown and Peck wasted no time in promoting Tesla's motor. They first sought independent testing to ensure it performed as promised, then coordinated a press blitz, sending press releases to technical journals. Physicist William Arnold Anthony verified the motor's performance, and with the help of electrical world editor Thomas Comerford Martin, Tesla demonstrated his motor at the American Institute of Electrical Engineers on May 16, 1888. Engineers from Westinghouse Electric and Manufacturing Company, who were attending the event, immediately took notice. Tesla's AC motor was just what George Westinghouse, head of Westinghouse Electric, needed. Westinghouse had been competing fiercely against Thomas Edison's DC systems, but his AC systems had faced limitations. Seeing Tesla's motor as a potential solution, Westinghouse wanted to license it. However, Westinghouse faced a dilemma. Italian physicist Galileo Ferraris had recently presented a similar motor based on a rotating magnetic field. To determine which design would be more viable, Westinghouse's team quickly assessed both, concluding that Tesla's design held the competitive edge. In July 1888, Brown and Peck successfully negotiated a licensing agreement with Westinghouse, securing $60,000 in cash and stock for Tesla, and a generous royalty of $2.50 per horsepower generated by each motor. To sweeten the deal, Westinghouse also hired Tesla as a consultant at his Pittsburgh laboratories, offering an impressive salary of $2,000 a month, equivalent to around $68,000 today. Tesla accepted, moving to Pittsburgh to help integrate his motor with Westinghouse's systems. However, he soon faced challenges. Tesla's motor was ideal for industrial use, but proved problematic for powering streetcars, which required varying speeds. Frustrated by the limitations and by disagreements with Westinghouse's engineers, Tesla reluctantly allowed them to pursue a DC motor for streetcar systems, despite his conviction in the power of AC. The War of Currents and Financial Struggles. While Tesla continued his work, the electrical industry was in the midst of an intense rivalry, known as the War of Currents. Westinghouse, Edison, and Thomson-Houston were each vying to dominate the growing electricity market, fiercely competing for contracts and capital. Edison, determined to undermine AC, launched a public campaign portraying DC as the safer option, sometimes with backing from Thomson-Houston. Tesla's motor showed promise, but Westinghouse struggled to scale production quickly amid this competition. Then, in 1890, disaster struck. The Barings Bank in London nearly collapsed, setting off a financial panic. Investors, fearing losses, demanded repayment of loans, and Westinghouse found himself suddenly short of cash. To avoid insolvency, he was forced to refinance and agree to cut costs. Under pressure from his new lenders, Westinghouse had to rethink his spending, including the costly royalty arrangement he'd agreed to with Tesla. Despite the promise of Tesla's motor, it remained largely untested in practical settings and wasn't yet widely adopted. In early 1891, Westinghouse approached Tesla with a plea for help. Explaining the dire situation, he told Tesla that if he didn't meet the lender's demands, he would lose control of his company. This meant Tesla would have to deal with bankers to secure his royalties, and his invention might never see widespread use. Tesla, understanding the strategic importance of Westinghouse's support for his motor, agreed to waive the royalty payments. This selfless act gave Westinghouse the breathing room he needed, and it kept the AC motor's future alive. A legacy secured, over the next few years, Tesla's motor slowly gained traction. In 1897, as part of a patent-sharing agreement between Westinghouse and General Electric formed by the merger of Edison and Thomson-Houston, Westinghouse purchased Tesla's AC motor patents outright, paying him a lump sum of $216,000, a considerable sum at the time. Tesla's work with AC systems became a cornerstone of modern electricity, though he wouldn't enjoy the full financial rewards his invention brought to the world. Yet, his AC motor and polyphase system paved the way for the global adoption of efficient electrical transmission, lighting homes and powering industries. Tesla's journey reflects both the triumphs and sacrifices of innovation, a visionary who propelled technology forward even as he faced financial and personal challenges. In the end, Tesla's AC induction motor changed the course of history, enabling the spread of electrical power across the globe and securing his legacy as one of the most influential inventors in electrical engineering.